SQL Server is an important database to understand as a developer, not just as a C# developer. In fact, it's one of the most popular requirements on job listings for developers. So I thought we'd take a bit of time to dive into some important parts of SQL. In this lesson, we're going to look at SQL Server Management Studio. We'll look at what it is, how to use it, and why it's valuable to understand when working with SQL. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I do that by providing videos here on YouTube multiple times per week, plus I have a weekly podcast. I also provide courses on C#, web development, and much more at IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube so that everyone can have a great education in C#, not just those who can afford it. So let's dive right into what is SSMS. So let's first talk about getting it. And here is the link. I'll put this in the description, but this is the link to download SQL Server Management Studio. What this is for working with Microsoft SQL Server, which is what we're going to focus in on today, is Microsoft SQL Server. So this is think of this like the Visual Studio for SQL Server. And in fact, SSMS does not come as part with the database too. You download SSMS separately. This is the tool to work with a database. If you need a database, you can either go here, and this is another link I'll put in the description. This is the link to download SQL Server, and yes, you can download a free version. Notice down here, the Developer Edition is a free specialized edition. This is the full-featured free edition, which is licensed for use as a development and test database in non-production environments. So this is going to be like a full SQL Server, but it's free to use. This is what I'd recommend you do if you really want to have the full experience of SQL. Now, there is SQL 2019 Express, which is free. It's for development and production for small applications. So you can use Express for free, and it's licensed for production too, not just development. But if you're going to get into a corporate environment, if you're going to be using SQL Server in any larger capacity that includes getting paid for the work, you probably want to have Developer installed to have all the nice features and tools that you'd have with SQL Server. But either way, you could get one of these. However, I do want to point something out, and this is important, and that is SQL Server does take up quite a bit of resources. It's designed to run on a server where it's kind of like the only thing on the server. It's kind of designed to take up as many resources as possible. Now, you can limit that, and you can change things, and you can tweak it if you want, but just know that's what it's designed to do out of the box. And that's actually a feature, not a bug. The feature is that it's designed to use as many resources as possible to make your database interactions as fast as possible. But when you're installing that on your own personal machine, that can be a bit problematic. So just know that if you don't have a fast machine, this might not be the solution for you. Don't worry, there are other solutions. For instance, down here, you can run SQL Server in a container image with Docker, which means you can very easily spool it up and turn it off as needed, which will make life a little easier for you as far as your system resources that it's using. So that is another option as well. We're going to use a third option, though, in this video, and that is, I'm assuming that if you're watching this video, you probably have already experienced my other content. If not, welcome. Glad you're here, and don't worry, this will be very, very relevant to you. But if you are a C# developer or aspiring C# developer, if you already installed Visual Studio, then there is another option. So let's minimize this. And if we go over to Visual Studio, I already have it open, but the SQL Server Object Explorer, which if you have that installed on the View menu, you can get to this, SQL Server Object Explorer. There is an option for installing database tools and database functionality in Visual Studio. If you have not checked that box, you may not have this option. But it is a free, just go to Tools, get Tools and Features, and enable that. But the SQL Server Object Explorer, one of the things it does is it allows us to work with SQL very easily, including LocalDB. And what LocalDB is essentially just a database file in one. It's a little bit more like SQLite, not quite the same, but it's not as full featured necessarily as a full SQL instance, but it gives us the same functionality as far as working with SSMS or T-SQL or all those good things. We can still use it like a real database. So it's great for testing, great for small deployments where you're just trying things out locally to make sure they work. So we're going to use this actually with SSMS because I don't even have the full developer version of SQL installed on my machine. Now at this point, I do use a Docker container with SQL when I need to, but for the most part, I rely on LocalDB. In this case, we're going to focus in on this sample DB database that I have. Don't worry if you don't have it, you can create it, or you can just follow along and watch. So I have this LocalDB, which is at localDB/MSSQL LocalDB. That's where you can find my databases. So let's go back to SSMS. And this is what you're going to get when you first start off, is kind of a blank slate. It's blue, and it's going to maybe pop up with this dialog. And it's going to say, hey, where's your database? And that's the first thing that's going to show up, and you may not know where to go. Totally understandable. If you had installed your database locally, so if you had installed SQL Server Developer, SQL Server Developer Edition, then you would probably put a dot in this box. So you probably put a dot right here. And what that represents is your local machine and the root instance. So it just says, hey, on this machine, which that's what dot represents, is this machine. Or you can say 127.0.0.1 or localhost, but dot is usually the easiest thing to do. That represents your current machine. On this machine, there's a SQL Server. And then you have a couple of options. You have authentication. And typically, when you're doing local stuff, you either have Windows authentication or SQL Server authentication. Windows authentication says, hey, whoever I'm logged in as locally, that's who has admin rights to the database. And that's usually correct for a local database. Or you may have created a SQL Server password. So you'd have a login name and password. And traditionally, the login name for the system administrator is SA. So you might have a password. And I'm going to date myself here, but in the bad old days, we used to have the password of SA as well, because somehow we thought that administrators didn't need to have secure passwords. But now SQL Server says, no, you can't do that. Please don't do that. Let's have a strong password. You'll probably have something a little bit longer that you type in here. So this is whatever password you created when you installed SQL Server Developer Edition. Now, if you haven't installed that, don't worry. We're not going to connect to an edition that you don't have. But if you did, you would type it in here. You could remember the password. I tend to on my local machine, since the developer edition password is not something that has to be super secret. It doesn't have to be super complex or change all the time or, be closely guarded, because it's just your local machine. But now, let's pause here for a minute. If you are installing databases that have sensitive production information in them, you absolutely must secure your local machine. But then the question is, why are you doing that in the first place? You probably shouldn't do that. So with this, you would say connect at this point. But I don't have that. I'm going to use LocalDB. So I'm going to choose in this drop down here, LocalDB/MSSQL LocalDB. Now, you may not have that in the drop-down because you have not selected it before. So you have to type this out. So notice that it's exactly, and let's kind of zoom in here, it's exactly like we saw in Visual Studio, the parentheses and everything. So parentheses, LocalDB, /MSSQL LocalDB. And I'm using Windows Authentication. For LocalDB, that's what we use as Windows Authentication, because it says, hey, whoever's logged in as on this machine is the administrator of this file, this database. So we're going to connect to MS SQL Local DB. And notice on the left-hand side, we get a list of folders. Let's kind of zoom in here as well. This is what you'll see when you connect to a database server, to a SQL server. You can connect to multiple servers at once. So if I connected again and I chose a different one, I actually have another one saved here. I can connect to multiple at once. And now I have one that's my local DB and one that's actually in Azure. And this is where people ask me the question, well, Tim, how would I do this with an Azure SQL database? It's the exact same as a local database or one that's installed in your network. It's the same thing. You just have to know how to connect to it, what the path is or the URL, what the login name and password is, and you're good to go. And notice I used a login name and password for that Azure database. I can't use my Windows login because I'm not logged in through, I am logged in through Active Directory, but not the same Active Directory. So you'd have to be logged in through Active Directory and authenticated to the same Active Directory that manages your SQL Server. So instead of doing all that, I use a login name and password. So let's disconnect that one. But notice we can have multiple connected here. It's very nice for convenience sake to have more than one. So this is a connection to a database server. And again, it doesn't matter if it's local, if it's on my network, or if it's in the cloud like in Azure. The same principles apply. Once you have that connection information, that's all you need. And by the way, let's zoom back out here. When I said connect, and let's go over here to this connection, this information right here, the server name and authentication of Windows Authentication, that's really all you need for a connection string in C#. That information. If I had a login and password, so if I said SQL Authentication and I said, SA, and let's pretend I use SA from a password as well, not great, but I did, that would be the information you need for your connection string instead, is your server name, your authentication type, your either login and password or not if you are Windows Authentication. So if we go back to Visual Studio, and if we look at this database, let's select this and we'll go to Properties. And we look down here at Data Source, and let's see if we can drag this far enough over. Data Source equals, notice that same localDB / MS localDB. Initial catalog is SampleDB. And then it says integrated security. Let's see if we can, there we go. Integrated security is true. What that means is Windows Authentication, integrated security. And then the rest of the stuff is default stuff like connection timeout and encryption and trusted server and all the rest. But those are the big things to know is it integrated security or is it login and password? And then what the data source is, that's the SQL server. And then what's the initial catalog? Oops. The initial catalog is what database do you want to start with? And that's maybe one of the questions we need to answer right away is when I'm talking about connecting with SQL Server, I'm talking about connecting to a server, not a database. It's a database server. So a database server can house multiple databases. All right. So you can have one server and 1,000 databases on it. Now, traditionally, you don't have that many. Maybe we have 10, 20, or 30, or maybe even a few, like 2 or 3. But we can have multiple databases. That's why the first folder here is databases. Which databases are going to work with? Now, we're not going to cover all this stuff because this is an intro to SSMS. I want to cover the most valuable things for getting started with SSMS. So we're going to start in the databases folder. In here, we have, now I have multiple databases. You might not have any yet because you haven't created any, and that's fine. But there are things to note here. First of all, if you right-click on databases, you can say New Database. And from this, I can create a new database. So I can say Tim test. Now, there's lots of options in SQL Server, and you might say, man, it looks overwhelming, and I get that. And the reality is that when you're in a corporate environment that relies on the database, and most corporate environments do, you should probably have someone that has a deeper knowledge of how SQL Server works, do the actual in-depth work with SQL. However, not everyone has to have that level of depth. You should at least have a cursory knowledge of some of these things, though. So, for instance, whenever you create a database, it creates two types of files. You have your actual data file, and you have your log file. So we have an MDF and an LDF file. And in a optimized corporate environment, these files would probably go on separate drives. That way they can have the read writes for that drive only, as opposed to sharing it with the other database or file. So just know there's lots of options here, but really you just need to have a name. Don't put a space in it. Database owner can stay the default. There are options in here, lots of options. And again, as you get into buildings for production, you should know more about what options to choose. But for just playing around, just starting out, just putting your database name in is probably fine. You hit OK, and now you have your database. So if you don't already have a database, that's all you need to do to create one. Right-click on the databases, new database, put the name in, no space. Okay, so now you have something to play around with. I'm actually going to come into Tim's test, and we're going to use Tim's test a little bit, but we're also going to use this sample DB because I already have a couple of spots in there to look at. But in here, if you expand out the database, we get more folders. Cool, love folders, right? Well, they do organize things. So we have database diagrams. We're going to skip that because it's not the most useful thing in the world. It's not going to be the place that I go to very often. All right. I would start with tables because the purpose of a database is to store data. Where do you store data? In tables. So let's look at the tables. If we open this up, notice there are system tables, file tables, external tables. Also notice in the database itself, there's system databases, and there's 4 in there. Don't touch those. Leave them alone. Those are Microsoft's. Leave them alone until you are much more advanced. Leave the system stuff alone. Just deal with your own personal stuff. But inside of tables, we can right-click and say New Table. Now, I get more into creating tables and what some best practices are and so on in a future episode. But for now, just know that's how you create a table. We would fill out the information for the column name, the column type, without allowed nulls, create a primary key, and all the rest of the stuff we can do in a table. Now, we can also have other options like views, and then we have under programmability, I kind of buried this, we have store procedures. So those are probably the 3 when you're first starting out that I'd like you to concentrate on: tables, views, and store procedures. And in fact, if you want to prioritize tables, then store procedures, then a far third of views. So what's the purpose of each of these? Well, a table stores the data itself. That's where all the data gets stored, is in tables. And then a view allows you to create essentially a query that kind of mashes up those tables together and creates what looks like a table from running it perspective, but behind the scenes is doing some type of querying against one or more tables to get you that view. And then store procedure is kind of the same thing. It can do that querying, but it can also do action queries such as insert, update, delete, and so on. And it does so in a slightly different way. And we'll look more at that in the future. I do have a whole video just on creating store procedures. you could check out. But those are pretty cool. And yes, they're still relevant even today. Okay. So that is the basics of SSMS. Now, there's lots more here, but I want to show you a few more pieces of SSMS to really get you started working with it. So we've already connected with a server. We've looked at and created a database. Now let's open up a different database that already has tables in it to see what a table looks like. So let's right-click on this and say Design. Right-click is your friend in SSMS because it gives you a lot of options. So for instance, let's look at this right-click option. So we could design it, which means we can actually look at the design of it and even change the design. We could, this is a shortcut, select the top 1,000 rows. So if you just want to look at, hey, what's in this table? We can select the top 1,000 rows. Or we can edit the top 200 rows, which means that it allows us to actually make changes to the data in those rows. In a production environment, don't use that option. Just don't. Leave it alone. But this one is super helpful to select top 1,000 because it gives you a good idea of what the structure is and what the data looks like in that table. We can also do scripting, where you can create a new create script. So if you wanted to take the structure of this table, which everything in SSMS, everything in SQL is built off of a scripting language called T-SQL. So this would create the T-SQL statement for you. Let's just do that real quick. Open a new query editor window. We can also save to file or to the clipboard, but let's just open a new window. And this is what the create statement looks like for this table. So if you were going to write the T-SQL script to create this table, this is exactly what you would write. Now, I'd probably clean it up a bit. We can just get rid of all of that. Actually, let's not yet. Let's get rid of this. This is just setting some basic standards for what's turned on when it comes to the editor. But let's get rid of that, and we'll leave this statement here. So this is T-SQL. And again, we're going to create a future video that's going to cover an intro to T-SQL. That's going to talk more about T-SQL. But the basics are here. You can zoom in here like that. Nice. We first say use SampleDB. What's that doing? Well, what that's doing is making sure it's in the right database. Notice that the database name is called SampleDB. Why is that important? Well, because if we ran this script in a different database, it would create the table in that database instead of the one we were intending. So let's make sure that we're in the database we intend to be in. However, if you were taking this script and going to put it into a different database, you would need to change this to be the name of a database you want to have this table created in. So for example, if you want to change this to Tim's test, if I say Tim test for the database, notice the right squiggly goes away because there is no table called people in that database yet. So it would use that database, Tim test, and that would create this table. All right. And again, we'll go over more of these options when we talk about the intro to T-SQL. So with that, we can execute. And that's this green button right here, execute, or F5. And if I do that, it says command completed successfully. We come down here to Tim test and you look at the tables and we have to refresh. So right click to your friend, refresh, and there's the people table now because it has now been created in that database because we ran this T-SQL script. Now, if we try to run it again, it's going to fail. There's already an object named people in that database. So this create only will work once. Now, that's how we can use that right-click menu to our advantage. Let's close this out. We'll not save it. We can also right-click on here and say script as drop or drop and create. So drop and create, what it does is it says if it exists, then drop it. Now, here's the really dangerous part. Guess what's going to happen to all the data in the people table? It's going to go away. So that's a very dangerous script to run. Be careful what you do. Yes, you can make significant issues for yourself if you just run whatever script you feel like. So be careful when you're trying these things out that you at least think through what the action should be and whether or not you're okay with that. But down here, we have a lot more stuff we can get into, but we're going to stick with design. And I think this is, especially for a newer person getting into SSMS, this is the easiest one, is design. Because here you have a visual designer that's telling you essentially the same thing the script did, but in a way that is visual. So if you want to add a new column, well, these are the column names. We could say test, and we just have to give it a type, which whatever type we decide we want to choose, let's give it an integer type and whether or not you want it to be null. And that would be it for adding a new column to that table. I'm not going to do that, but we could. We just have to hit save, and that would run. So it's a nice visual designer. Now, that is how to work with and how to interact with this left-hand column here, where we can right-click on something and say, select top 1,000. There you go. There's only 7 in there, but if we had more than 7, show more than 7, up to 1,000. But there's also other things you can do in here. You can also right-click in your database and say script database as, or new query. This is the one I use a lot, is new query. So a new query is just a blank window. And this is what I love to work with in SSMS, is a blank window, because it allows me to try out things, test things, get more information very, very quickly without having to open lots of windows. But let's look at what this window is doing. Okay, so first of all, in the upper left-hand corner over here, we'll see this dropdown says sample DB. What does that mean? It means currently the database we're using in this window is sample DB. If I were to drop this down and change this to TimTest, it's now using the TimTest database instead. So if I were to come down here and say select star from dbo.people, and I were to run this, execute, it says there are no people in the table. And I say, but I'm sure there are. And I go, oh, I have to come up here and change this to sample DB, a different database, and execute it. And there are people in that database in that table. So just know that that can burn you. Knowing which database you're in is important. So make sure that dropdown is selected properly. Also notice that when I was in Tim's test, it gave me the squiggly invalid object name dbo.people, but it's not. It's not invalid. And the reason why is because the database has not, or the database of what's available has not been refreshed. So I just did it, Control-Shift-R, and now it knows that people is there. So we created the people table just recently, and SSMS hadn't been refreshed yet with what tables are where. So by doing Control-Shift-R on Windows, obviously, I refreshed the query window to get the latest information on the databases. So let's go back to sample DB. And again, we're going to learn more about T-SQL in probably the next lesson. We're going to get more into the intro to T-SQL itself and how this all works. But essentially, what I've done here is said, select every column from this table. And the table is dbo.people. Now, I could have said people. I could say just people, and that would still run. But I say dbo.people because dbo is the owner. And notice over here, it says dbo.people. In general, with small databases, with test databases, everything will be DBO, everything. But when you get into production environments, into real world scenarios, you will have different owners. So it might say sales.people or HR.people. So that would be important to note which one, because you might have two different tables in your database called people, one owned by sales and one owned by HR. So you need to know which one by specifying the owner. So really, there's some hidden stuff here. It's actually sample db.dbo.people, and that executes as well. Think of this like a namespace in C#, where we don't have to specify this because we're already in that database. But here's the cool thing. If you did specify it, which is quite large, but if you did specify it and you're over here in Tim test and you run this, we still get all 7 people. Why? Because even though we're in Tim test as the default database, we said, yeah, we know it's the default database, but we're actually specifying the table from this database. So that can be useful if you want to go that far, but I don't typically go that far. I just do this. The benefit here is that as you run these scripts, they will run in your development environment and they will run in production, which might have a different database name than your development environment database name is. So this way they'll run either way, just depending on whichever database you run them on. So that's why we typically don't put the database name in the query string. Now, I can also say select star from dbo.addresses. Now, if I were to execute now, notice there's 2 different results here. There's one that is the people, that's right here, and then there is the addresses. So why do we have 2 different results? Well, the reason we have 2 different results is because we ran 2 different queries. We ran this query and this query. But here's a really cool thing about SSMS. If I highlight one thing, for example, this, and I hit execute, it runs whatever is highlighted, not the entire file. So I use a query window like this as a scratch pad. Well, I have multiple things here, and I can just keep writing queries and then just highlight what I want to run and execute just that query. Now, it is something that you need to be careful of. Let's just come back over here and execute this. Let's do a simple where clause. Where first name equals Tim. Okay, so this right here returns 1 record. All right, you can see the 1 record right there is just Tim from Texas. And I only ran just that 1 query because I highlighted the whole thing. But what if I accidentally highlight the wrong part of it? Well, it's going to give me every record because I didn't highlight the where clause, which is not a big deal if you have select statements, but be careful with things like delete statements, where you're saying delete from this table where, and you forget to highlight the where, and then you delete every record from the table. So be careful of this functionality, but this is a really nice option for just running the query that you want in this window. Like I said, I use one of these query windows as a scratch pad all the time. Okay, so that's a nice feature of our window, but there are other things that I want to point out while we're here. Now, if we kind of zoom in up here, we have some options, okay? So we have the actual execution plan, live statistics. We also have the estimated execution plan. So what are these things? Let's look at the estimated execution plan. Okay, let's come up here. Whoops, it ran for both of them. Okay, well, no big deal. So since I clicked on it and nothing was highlighted, it ran for both of them. An estimated execution plan says, this is what I'm going to do, I think. So this is something to think through when you're thinking through how SQL Server works, is that when you are getting data out of a database, SQL Server has to optimize how it gets the data so that it correctly figures out what is the best, most efficient way to get you your data. Otherwise, it could take forever. Let's say you have 1 million records and you want to get the record with the ID of 1. Just 1. And it's the first one, right? Just the ID of one. And you've got a million in there. Well, would you want SQL Server to look through every single record and go yes, and then no, 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 a million times? Probably not. You'd probably want to be more efficient than that and say, hey, I found that record. That's all I need. Well, that's what an execution plan is all about. Is the SQL Server engine figures out what's the fastest possible way I can get the data back to the user. This is why I highly discourage people from just saying, give me all the data, I'll then filter it in C#. Because that's not what is most efficient. It's most efficient to let SQL Server do what it does best, which is efficiently filter, sort, and return to you just the data you need. So this execution plan says, hey, here's how I'm going to go about getting this data. Now, there's a lot more we can go into here. We're not going to cover all about indexing. There's ways to do indexes well. Essentially, an index is a copy of part of your data in order to help SQL Server more efficiently target just the data you need. It will figure out what the most efficient index is. Be careful, don't just throw indexes all over because it is a copy of database or copy of the data, so it actually makes writing data slower in order to optimize reading data. With all that said, this execution plan will show you what it's going to do. Now, in this case, we have super simple queries. Just select star and select star where. But it is important to note that they're both doing what's called a clustered index scan. What that means is they're going to look through all the records. That's what they're going to do. And the reason why is because there's so few records, it doesn't matter. It's not worth it to be more efficient than that. So therefore, they're just going to look through all records. But if you had a million records and we were looking based upon first name equals Tim, it might say, hey, I could use an index here on Tim because that can make this a lot faster. But if you looked it up based upon the ID, I believe I have an ID in here, equals 1. And let's do the estimated execution plan on this. There we go. It says, this one says scan down here, clustered index scan. This one says clustered index seek. And the difference is it says, hey, I have a way to go right to that particular record using the primary key. So that is an index on my table. And this search uses that index. So I can go there very fast. Now, if you notice, since it ran both of these together, it says query 1 relative to the batch costs 50%. And this one, query 2, costs 50%, which means these queries are equal in terms of speed. And the reason why, again, small sample set. Okay, as you get bigger, there might be some differences, especially if you have different types of where clauses or different joins and so on. But this kind of gives you an idea of how efficient your query is going to be, especially if you compare it against another option. Just be careful when you start seeing things like, okay, if you notice here, it says there's an estimated I/O cost, an estimated CPU cost. And you might say, well, what are those? Is that CPU cycles? These are not numbers you can quantify like that. They have to be compared to other numbers. Yes, bigger CPU cost is worse. And that's what you're really comparing against. Hey, this takes a lot of CPU cost. I want to reduce that somehow. But there's not like this is so many cycles or so many ones and zeros. It's not that kind of cost. It's a relative cost. But it does kind of give you an idea, especially when you run it in comparison. So if this was two different ways to do the same thing, notice there's no difference. So if someone came to you and says, we have to do it this way as compared to this one. Now it's apples and oranges, different tables. But they say we have to do it this way versus this way because this way is so much more efficient. You can go to an estimated plan and say, actually, they're about the same. Now, this is estimated. there is another plan up here. It's called Actual. And yes, these icons are practically the same. This is the 3 boxes with a little gray triangle at the lower right-hand corner. This is the 3 boxes without that little gray triangle. So the actual execution plan just turns on a feature. That's it. So nothing actually happened. This is still the estimated execution plan. But if I run execute, then we have a third tab over here called execution plan. And it shows exactly what it did. So what's the difference? Well, the estimated execution plan says, this is what I'm planning to do, but when it goes to do it, it might go, oh, we made a mistake here. We need to rethink how this thing works and do something differently. So when it runs the query, it will let you know afterwards, this is what I actually ended up doing. And it will also give you additional numbers in here that will tell you, what it actually did, number of rows read, and actual number of rows for all executions. So there can be things in here you can investigate like, hey, you expected to return 10 rows and you got 10,000. What happened? And it can, kind of tell you, hey, I made some bad assumptions. And that's where SQL Server will optimize itself, but also where you can start coming in and saying, hey, we need to, update some indexes or change how things are done. But this is the actual execution plan. So if someone came to you and said, well, let's just make it apples to apples. These two are not the same thing. This one's super efficient compared. Well, where first I want to make sure it's apples to apples, the same thing. So both of these return 10. Look at the execution plan. They're exactly the same as far as how costly they were. The only thing I would caution you on is don't do this with development data. I have, 7 rows of data? That's nothing. Do this with a sanitized version of your production database that has 100,000 or 1,000,000 records. Then run this. If you did, you will find that your index scan is less effective than your index seek. So yes, this will become much better in production versus this one. But if you're in production, if you're using production data and you have 2 different camps as to which query is more effective, or you're trying to figure out which one's more effective, use the actual execution plan, run it, or the estimated, and estimate a start and then verify the actual. But check it out and say, oh, this one, the first one, it only takes up 5% of the overall batch compared to the other one. Now, again, that's a comparison. It's not saying that this is 50% of the overall work. Like, it's not saying that it's 50% of your CPU time for X number of minutes. It's just saying compared to the other one, that's what this. So if this said 5% and this one said 95%, then the first one would be 20 times more efficient, okay, versus the other one. So just note that's how to use the execution plans. Estimated to get you close, make sure, and then you verify with the actual execution plan if possible. So some really cool stuff you can do there. You don't have to run that all the time. And if you run it just for one, it gives you the execution plan still. You can still kind of understand how the query is working, but it's not going to give you that comparison against something else to verify if it's more or less efficient than what you were expecting. Okay, so this query window, super helpful. If you want more, right-click on a database and say New Query, or even up here at the server level, New Query. But notice at the server level, it might not be in the same database you were in, so you'd have to change it to the correct database. Just note that. So there's lots of cool stuff you can do in here with SSMS. There's lots of great features, but that kind of gets you started. You can right-click on stuff and say, new database. You can say under tables, right-click on it and say new table. Under views, right-click and say new view. Under store procedures, under programmability, right-click and say store procedure. I'm not sure why it doesn't say new, but it doesn't. And then you can, create whatever objects you want. You can use this query window to to search, to filter, to create new records, whatever you need to do in order to kind of manage your tables. Now, this is SSMS. This is the tool that really is for managing a database server. There's lots more in here, especially when it comes to things like security and backups and all that good stuff. It's definitely a lot to learn in here, but as a developer, you should start to know it at least somewhat. There is another option if you're a developer using Visual Studio. You can use that SQL Server Object Explorer. You can right-click and say, I want a new query, and this probably looks familiar. Doesn't have all the features of SSMS, but it has some of them. And you can say, select star from dbo.people, and then you can run this. Notice it's not attach. It's down here. There's an execute, which isn't F5, which is super helpful or convenient normally, but F5 is the run in Visual Studio. So instead, it's Control-Shift-E, or just hit the button, and that gives you your results. So you can stick right in Visual Studio and still do a lot of this stuff, but SSMS does have kind of some more features that are helpful. It's the way to manage an entire database, not just do querying. But that's kind of the intro to SSMS. I think that if you are a developer that has anything to do with SQL Server at all, you should have this installed in your machine and know how to use the basics of it. But again, when it comes to hunting for a job, almost every job listing for a developer is going to have some type of database requirement, and a lot of those will say SQL. They don't all mean Microsoft SQL. Some mean SQLite or MySQL or something like that. But in general, Microsoft SQL is going to be a pretty high contender on that. And this SQL query language that we're seeing here, T-SQL, is pretty universal. Okay, there's kind of flavors of it for things like, SSMS is a little bit different than MySQL. It's a little different than SQLite, but for the most part, it's the same. And so if you learn one, you'll have a really good handle on more of them. And I'd really encourage you, especially as a C# developer, to know Microsoft SQL. So know SSMS, know how to use it, and know how to work with a Microsoft SQL database. All right, so if you have questions, let me know. I do have a suggestion list at suggestions.imtimcorey.com if you have a suggestion for a future video. But if there's something in this video you're like, man, I wasn't quite sure about that, leave it down in the comments. I'll try to get to it. I'm actually on vacation coming up, so I will be at the beach checking in once in a while. But I am going to have another video coming out next about T-SQL. So knowing more how to write these queries. Select, insert, update, delete. We'll talk about that coming up. So let me know in the comments what your thoughts are. If you use SQL, let me know. If you don't, why not? If you don't know SQL, what's kind of holding you back from knowing that? And just be aware, if you say, well, I use Entity Framework, that's not enough, okay? It's not just my opinion, but it is my opinion that even if you know Entity Framework, you should really know SQL. So I have a whole video on Entity Framework and Entity Framework best practices, and one of them is to know SQL very well. And I show you a number of reasons why just knowing Entity Framework will actually hurt you and your database performance, but it won't show up right away. It will show up in production when it's kind of too late. So this is a word of warning. I have worked as a consultant with a number of companies who have regretted Entity Framework, but not until it was too late. So I am not saying don't use Entity Framework. I am absolutely not. Entity Framework is a great tool, but you have to know how to use it well. That's my thing, okay? It's a very powerful tool, but there's a lot to know about it. And part of that is knowing how to be a SQL developer. So knowing this is still very, very important, even if you decide, hey, I want to use Entity Framework to access and update my database. Okay, so again, leave your comments down below. I'd appreciate it. Thanks for watching. And as always, I am Tim Corey.